And good afternoon everyone, and we will going to start with the new discussion. And here we can say the discussion number 1. This is the block. Now this is the block, and you can see the block A is tied with spring, and let's say spring constant K, and block B is tied with a string, and this will be applied some force. Fine, it will be applied some force onto it. Let's say the force is applied as F. We have to calculate, let's say moving with acceleration A. So as A, you can see A is, it is given already. This is given acceleration A, and what we have assumed, the force F is applied. When the force F is applied, so you have to calculate by what acceleration the block has to move. And one more information it is given, B and A are moving relative to each other with constant velocity. Fine, with a constant velocity. So here I have drawn the free body diagram of ABC. So free body diagram of A, you can say A, it will be applied by normal reaction via C, and Kx by spring and mg. This is a free body diagram of A with respect to ground. But once you will draw with respect to the block C, so you can say one with respect to block C, we can say some pseudo force acting. So this is the pseudo force, it is acting on it, and the normal reaction, we can say normal reaction Kx and mg. Now since with respect to C, A is not moving, so we can say the total horizontal direction, it will be in equilibrium. That's why I have put n is equal to mg. Now once n is equal to mg, and the vertical direction, since it is moving with constant velocity, hence we can say Kx minus mg is equal to 0. So this is equation 2. Fine. Now similarly block B, we can draw the free body diagram. And now block C, once you draw the free body diagram, Ma is, this is a pseudo force acting on it, and again normal reaction dash mg and T. As you know, the T is equal to, we have calculated in the upper equation, we can say Kx is equal to T, and Kx value is equal to Ma into G. So I have substituted in the given equation. So T is equal to Mb into A. This is the equation for block B, upper block B, and T is equal to Kx, that we have established already the relation. So now this is a free body diagram of C. Now we see we can easily calculate F minus N, as you can see normal reaction by block A, force F, and upward direction n dash acting. So the normal horizontal direction n minus F minus N is equal to mc into A. So from there we can get the value of F as Ma and mc into A. So this is the question it was asked, and very conceptually the problem it was asked earlier. Let's say very similar problem. This is very similar problem, problem number 13. Now problem number 13 is very similar to it. We can say F is applied. Now this time around what they have given, the block A is moving with acceleration A. Fine. Now the block A is moving with acceleration A. So as you know, once again we have to draw the free body diagram of A, free body diagram of M2, and here we can say M2. Now with respect to a bigger block like capital M, Let's draw quickly the free body diagram of it. So normal reaction, and the pseudo force acting, that is M into A, and upward direction T and downward direction mg. Clear? So with respect to C, we can say N should be equal to ma, because it is in equilibrium. With respect to C, this is the equation, N is equal to ma, or we can say m2a. Similarly, we can write the free body diagram of this is m1a, the pseudo force acting, tension T, and this is what the horizontal direction it will be acting with. And if it is moving, block A is moving upward direction, fine. So here we can say total force, because since it is moving upward direction, so in the given from right to left, the equation would be m1a, correct, minus T is equal to m1 into 2. This is the equation for the block, because by 2 acceleration it is moving upward direction, but here the pseudo force is also acting on it. So A is unknown, T is unknown. This is equation number 1, and N is equal to m2a, and in vertical direction we can form the equation for this block. It would be T minus m2 into m2 into g, that is equal to m2 into 2. So with the help of these two equations, we can get the value of like T, correct, we can get the value of T with the help of these two equations. m2 and m1, it is already given in the question, I thought, 10 and 20, and m2g. So from this equation we can get the value of T. From this equation we get the value of T. Once we substitute in the given equation, we can get the value of A. Once we get the value of A, once again the free body diagram for bigger block, let's say bigger block force, this is a normal reaction acting on it, fine, and is there any other force acting? No. So here we can say F minus N is equal to M into capital M, in fact, into A, and n is equal to m2a, we have already done. So F is equal to m2a plus capital M into A. Once we have taken A common, so m2 plus m. This is a very similar equation that we have received in the earlier question. Now once we get the value of F is equal to, so m2 is known, m known, F we have to calculate, A we have already calculated by these two equations. So once you put the value of A, we will get the value of F. So I thought you have now very clear idea how we proceed. You better to make those equations, block these two equations separately, then the free body diagram of last, and we can make it out afterward. Fine. So these two problem is very much connected. you can try afterward. This is the problem that you're supposed to. Now this is the problem. That you do very similar problem, block A, block B and C, and here you can see the mass is also got the same expression, MA plus MC into A. So I thought these two problem is very similar, kindly try, and the question already asked in 2022 examination. So now let's move to the next case, next problem, and the next problem is, here we can say, now problem number 4. Problem number 4, that initially the situation is, once capital M block is there, it is tied up with the spring, the equilibrium situation reached, and once the equilibrium situation reached, we can say at that point the M1 has a momentum as M into V, and V is equal to A omega, as you know, in the equilibrium, from equilibrium position to some extreme position, once the block start moving, to what will happen, V is equal to A omega. So as we know, the maximum velocity attained at equilibrium position, and once the M will reach to the mean position, we can say, so what is the momentum at that mean position, we can say M into V, and V is equal to A omega, because A omega is the maximum velocity, and once any particle will execute simple harmonic motion at the mean position, it will have the maximum velocity and value is A omega. So here I am applying the principle of conservation of momentum at mean position. So mean position, we can say velocity will be attained by the bigger mass. Now what exactly happened, I have put some next mass M on it. So we can say once again, here what I have done, I have making the momentum conserved. Initial momentum, that is on horizontal direction, that is just equal to the final momentum. Final momentum M plus M, let's say it will attain some new amplitude and new omega. So this is a very important concept. When we put anything gently, some M next mass put on this capital M, we can say by conservation of momentum we can get the new amplitude of it. As you know, the amplitude will decrease. Now the question number 5th, you can see this is a ring, spring. In fact, a spring got cut into two equal halves. So always remember, K into X will always remain fixed. So this is a situation, L1 and L2. L1 is n times of L2. So what you need to do only, you have to always remember K and L. KL is always constant. K1 L1 should be equal to K2 L2. So by this equation I have reached to this conclusion. By putting the value, we can say K2 by K1 is equal to N times. So once the spring cut into two halves, K will always vary, always remember. This is not a characteristic property, never going to be constant, but it will vary with respect to cross section. Once it will cut in two equal parts or many parts, we can say L1 K1 should be equal to L2, K2 should be equal to L3, K3 and so on. Fine. Now next problem number 6, we can say these are the two masses. Once this capital B mass will be pulled by force F, fine, once it will pull by force F. So here we can see once it will be pulled, so mass M, this is the mass M is attached to the spring. Once it is attached to the spring, we can say this mass M will surely have some elongation, and spring nature, for the sake of spring nature, it will attract the mass towards itself. So here the force that you can able to see the reverse direction of, this is the force that is acting towards the spring, that is the restoring force. I have expressed by SF SP. SP means spring force, and spring is massless, and this is FXP, because spring force trying to pull the mass, so it will once again attain the natural position. Fine. So in the question it is given the block in this particular block A, we can say, or ball A has a acceleration A. So basically the formula of spring force F is equal to, here we can apply the formula as F, because only spring force that will pull the block towards the B. So MA, that is M into A, that is given already. Now for this particular section we can say F minus F spring, that should be equal to M into AB. Now with the help of equation 1 and 2, what we can say, this is equation 1, this is equation 2. With the help of these two equations we can say AB we can calculate. So this is the equation 3, this is a basic equation of spring situation and elongation. So earlier question we have seen the string got cut, string got attracted, and the previous question spring got connected. So these are the three different situation of it. Fine. Now here we can say this is very simple problem of, and this is a very famous. Here we can say this is the movable pulley and this is a fixed pulley. Always remember acceleration relation between movable pulley and fixed pulley. If movable move with acceleration A, so the fixed pulley has and the block that is associated with it, it will move always 2A acceleration. This you better to learn it. If moving with acceleration A, this will moving with acceleration 2A. Now this is a free body diagram. With the help of these two free body diagram, I can make the respective equation, and once we solve we can get the value of acceleration. Now in the question it is given by, it is 20 centimeter from the surface, like 8 kg is 20 centimeter. So what time it will take to hit the surface? So we will simply use S is equal to, initial velocity was 0, S is equal to ut plus half a t square. This term is 0, half a t square. A we have already calculated, as we are already doing. By this we can get the value of t. Fine. So this is also very interesting problem, and once you knowing the relation between acceleration, always remember acceleration and the time it will relating. And most important thing is, if you will get the acceleration, you can calculate anything. So I thought the situation it is clear to you. So we have already completed 4, 5, 6, 7, and this question we have already done. Now this is an interesting case. Now in this particular case, what we supposed to do, we have, like, this is small block M having acceleration b meter per second square, and this is the bigger mass M, it is given. Now here you can say it is connected with n number of movable sections. So what you supposed to do here, always remember there is one concept that is called as virtual work method. Virtual work method, we can say tension and acceleration product is always constant. Fine. T into A is always constant. So here we can say if the tension of small m block is T and T, let's say T and T, so it will be attracted by 2T, it will be 2T and 2T, so it will be attracted by 4T, 4T and 4T, it will be attracted by 8T, 8T and 8T. So here the total tension would be 8. So this M block, it will be pulled by how many cross blocks? 8T, 8 plus 4 plus 2 plus T. So T means 1, 2, 1, 3, 7 and 8, 15. So total tension to which block M is going to hold with it is 15T. This is for capital M. And what about small m? That is T. So it is given that this block is moving 10 meters. So what I have applied, always remember T into A is equal to constant. This equation I have applied. So T1 A1 is equal to T2 A2. T1 15, in fact 15T multiplied by A1 it is given as 10, and T multiplied by A2. By this way we can get the value, like A2 we have given B, the B value we can able to calculate with the help of this equation. Fine. So this is very interesting case. Always remember this is called as virtual work method. Product of T into A is constant. Fine. Now this is also very interesting problem. Here you have to establish once again summation T into A is 0. So here we can say, like earlier what we have as constant, it would be rather 0, because 0 is also a constant number we can assume as. So summation of T into A is constant. This is called virtual work method. Fine. So T into A is 0. So once you apply this particular situation, so we can say, now here T and T again 2T, 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 4T, 4T and 4T. Now let's say the whole system is moving downward, downward direction. So let's say this is also moving downward direction, and these two section it is also moving downward direction. Let's take the direction randomly, you can resolve afterward. So here we can say tension and acceleration will make 180 degree. So 4 multiplied by A1, then next is A2 into 2T, and once again they are different in angles because make 180 degree, hence minus sign is there. Now A3 and T, it is also once again minus sign. A4 downward direction, T it is minus sign. So once we eliminate all the minus, so equation that we get in terms of acceleration, that is already there. So this is a very important equation through which we can get directly, this is just like a shortcut through which you can get the acceleration very quickly. Always remember this equation. So we have completed this section up to now. The remaining section we have already done the discussion of vernier calipers, though vernier calipers is there, and screw gauge 0 positive error, that we have already covered. Now the next class we will going to cover the few problem that is based on unit and dimension. These are the problem that we will discuss the next class. Thank you.